Good morning, grade 11. Here's a video just to help to explain a little bit more about Newton's laws and sports and how the three laws of motion apply to different sporting activities. This should help with the lesson that you started on Sunday, just to explain some of the concepts, and I've got examples of the graphs that you were asked to draw then as well. So just to go over kind of what we're doing in general at the moment, we're looking at biomechanics. Okay, that's an application of mechanics to the human body and sporting implements, and studies forces on and caused by the human body and subsequent results of these forces. It's a huge area to get into, kind of new technologies that runners are using, for example, their different trainers that they're using with the carbon fibers in the trainers, and whether or not they should be allowed. They're all part of the study of biomechanics. All right. Within biomechanics, we've got kinematics, which is a study of motion, and then kinetics, which is the study of the forces that are involved. All right. So we've got linear motion, which is in a straight line, curvy linear motion in a curve, angular motion is around an axis, and general motion, which is linear and angular motion together, which is probably most motion that you would come across. We've also got linear kinetics, so forces, gravities, mass and weight, and then angular kinetics, which is torque or moments and levers that we've looked at already. So just continuing with the concept of impulse and momentum. On the screen here, not very clear, but you have got two images. One is of a bullet and one is of a huge truck kind of crashing into something. So which of these objects would be harder to stop? Would you really want to stand in front of either of them? Probably not. Why is that? Because their properties are very different. Okay, the bullet has a very, very small mass. The truck has a very, very large mass. All right, but either of them could do a lot of damage to you. So what is it about them that makes them have more of this, which is momentum? Okay, well, the bullet is hard to stop because it's traveling very, very fast. So even though its mass is small, it's traveling at a very fast velocity. All right, whereas the truck is hard to stop because it's got a very large mass. So it might not be going particularly quickly, and certainly would be going a lot slower than the bullet, but it still has that huge mass associated with it. Okay, so then it makes sense to assume that a bullet traveling twice as fast as this would be twice as hard to stop, and a truck with twice the mass of this would be twice as hard to stop. And that's all about momentum. Okay, you should remember this hopefully from grade 10. The quantity of motion of a moving body measured as a product of its mass and velocity. So what's that saying basically is momentum is the mass multiplied by the velocity. Okay, here's an example. You wouldn't need to actually calculate this, but it just helps to show you. So if we had a shot put with a mass of 7 kilograms and a velocity of 3 meters per second, its momentum is going to be 21 kilogram meters per second. Okay, now we get onto something called impulse. All right, this was one of the definitions that you should have learnt in the first lesson. But impulse is basically how hard it is to stop a moving object. So to stop an object, we have to apply a force over a period of time, and that is called impulse. All right, so the impulse is the force, multiplied by the change, and delta means change, in time. So if you can make something take longer, all right, then it's going to decrease the impulse. For example, if a cricketer catches a ball, all right, and they don't just keep their hands here, they move their hands, that's increasing the time that it takes for that force to happen. Therefore, the impulse is going to be decreased. Okay, another example might be if you are doing gymnastics. Okay, the floor that you do gymnastics on isn't a solid floor, it moves, it's sprung. Okay, what that does is, again, it increases the amount of time that it takes for the collision, therefore the force and the impulse decreases. Okay, so we'll have a look at an example of sprinting. So the relationship between impulse and increasing and decreasing momentum in sprinting. So from Newton's first law of motion, force is required to change a state of motion of a body. It will take a certain amount of time to apply this force. Impulse is the time that it takes for a force to be applied to an object or a body and can be calculated as impulse equals force multiplied by time, or the change in time. I got the information from the next few slides from this link down here, which you'll see in the PowerPoint that's on the website. Definitely worth having a look at that website. So, impulse is represented by an area underneath a force-time graph, and I've got examples of that coming up. The graphs in figure 23 show various stages of a 100-meter sprint. In the 100-meter sprint, impulse is only concerned with horizontal forces. As the sprinter's foot lands on the ground, their muscles contract and a force is applied to the ground, so that's their action force. And then, for every action, there's an equal and opposite reaction. The ground reaction force acts on the foot, which allows the athlete to accelerate forwards. The action of the foot in contact with the ground is referred to as a single footfall. It's important to note that in running, negative impulse occurs first when the foot lands. Okay, so as your foot lands on the ground, there is a negative impulse. It provides a braking action. All right, then after that point, the force can be exerted as a positive impulse occurs as the next foot takes off. So what does this look like in a graph? Well, at the beginning of a race, okay, the person is going from 0 meters per second and they are accelerating. All right, so there's a small negative impulse and a very large positive impulse. All right, this shows that the sprinter is accelerating. When we get to the middle of the race, they're probably going at a kind of steady speed. Okay, so the feet are making contact with the track. So there's still a negative impulse here, but as they push off the track, there would be an equal positive impulse. So here, both positive and negative impulses are equal, so there is a net impulse of 0. This means that there is no acceleration or deceleration, so the sprinter is running at a constant velocity. Okay, and towards the end of the race, they would be slightly slowing down. All right, that means that the negative impulse is going to be larger and the positive impulse is going to be smaller. All right, so the net impulse is negative, which shows that the sprinter is decelerating. Okay, so the forces are smaller going through the race at that end bit of the race. So here's an example of a question. Define the term impulse. There's a couple of definitions, but I think this first one is the best one. It's a product of force and time, the application of force over a period of time, and you could also say that it changes the velocity of the body. You could also say that it's the area under a force-time graph. Okay, you could also say that it's a product of the magnitude or the size of a torque and its time of application. I really would probably stick with one of those first two definitions. Okay, so look at this video in conjunction with the PowerPoint from Sunday's lesson, and hopefully you can see how Newton's laws will apply to sports. Thank you.